Discovered in 1789 by William Herschel, Enceladus is a small, snowy, and frigid world, which is one of Saturn's hundreds of known moons. It is Saturn's 18th largest, meaning it's one of the smaller of its major moons, with a diameter of only 500 kilometers across, around the size of Newfoundland in Canada. Despite this small size, Enceladus is of great interest to astrobiologists for reasons we'll see soon. Enceladus orbits at a distance of around 180,000 kilometers from Saturn and completes an orbit in 33 hours. This is less than half the distance that the Moon orbits the Earth, and given Saturn's size, this makes for some spectacular views in the skies of Enceladus. Standing on its surface, an observer would see Saturn very bright and prominent in the sky. Because of how close to Saturn Enceladus' orbit is, it's prone to several hour-long eclipses, where the entire moon is plunged into darkness. Although this series of eclipses is only possible a couple of years before or after Saturn's equinox, when its rings are edge-on, facing the sun. A few of Saturn's other moons are also bright in Enceladus' skies, especially Titan. For nearly 2 centuries after its discovery, nobody knew what Enceladus looked like. Then, in August of 1981, the Voyager 2 spacecraft gave us the first close-up images of this moon. These images revealed the bright, icy nature of Enceladus, looking almost like a snowball. In 2005, the Cassini spacecraft, dedicated to studying Saturn, began making multiple flybys of Enceladus and giving even more detailed views of its surface, revealing icy ridges, craters, and canyons. Enceladus' surface is covered in a very thick layer of fresh, pure snow. All of this snow is what gives this moon such a high reflectivity. In fact, it is the most reflective body in the entire solar system, reflecting over 90% of all the sunlight that hits it. Consequently, very little thermal radiation is absorbed, leading to an extremely cold environment. Enceladus has an average surface temperature of just 75 Kelvin. These cryogenic temperatures allow water ice to be as hard as granite on Earth and form Enceladus' crust. The surface of this icy moon is not uniform at all, and there are different features on different parts of the moon. Perhaps the most obvious example is the cratering pattern. The northern part of Enceladus is pitted with hundreds of bowl-shaped craters as large as 30 kilometers across. Because Enceladus is too small to have an atmosphere to protect it from meteoroids, we can say that it has been experiencing these impact events ever since its formation, implying that some of these craters, and thus the surface of this region, is billions of years old. By contrast, the southern part of Enceladus has grooves and ridges, and a significantly lower population of craters, and models show that these regions are under 10 million years old, and possibly as young as just 500,000 years old. Within the inner solar system, all 4 of the planets are known to have, or used to have, volcanic activity. Take the Earth and Venus, for example, which still have active volcanoes. Volcanism on these planets involves red-hot lava, which solidifies and reshapes the land. This is why both Earth and Venus' surfaces do not have an abundance of impact craters. Their surfaces are constantly being renewed. Volcanism is caused by a planet's internal heat retained from its formation billions of years ago, along with the radioactive decay of elements within its core. Heat tends to rise, so currents within the planet bring hot magma up from the mantle to the surface through fissures, which solidifies and smooths out any craters present before. The reason Mars and Mercury have so many impact craters is that their small sizes caused their interiors to cool off much quicker than Earth and Venus, meaning that although they had volcanic activity in the past, their interiors are not warm enough for it now. Enceladus exhibits a form of volcanism called cryovolcanism. Cryovolcanism is a common occurrence in the outer solar system, on several other moons and dwarf planets. Enceladus, as small as it is, does have internal heat, and this is caused by Saturn tugging and flexing the whole moon during its orbit, creating friction in its interior. This phenomenon is called tidal heating. There is no magma, but rather Enceladus's mantle is made of pure liquid water. This is a subsurface ocean which lies just below its icy crust, and tidal heating is the reason why water can exist just below the crust, while the surface is extremely cold. This ocean is pressurized, so it continuously escapes through fissures in the southern part of Enceladus. These fissures are known as the Tiger Stripes, 4 nearly parallel fissures that are erupting continuously. These cryovolcanoes eject 250 kilograms of material per second. A lot of it falls back to the surface as snow, creating a continuous light snowfall on the surface. However, because of Enceladus' small size, some of this ejecta can travel fast enough to escape its gravity entirely, entering an orbit around Saturn. This material is what composes Saturn's E-ring, and it is entirely sustained by Enceladus' geological activity. Perhaps the hottest topic concerning Enceladus is the possible existence of life in its subsurface ocean. Part of Cassini's mission involved determining the composition of Enceladus' ocean. It made several flybys of Enceladus' southern hemisphere, flying directly through the plumes. Using its onboard spectrometers, it was able to determine the contents of what it flew through, and reveal the presence of sodium ions, chlorides, and carbonates, suggesting that the ocean is salty, perhaps like our own oceans on Earth. Cassini also detected several organic compounds. Here's why this is significant. The leading hypothesis for abiogenesis on Earth involves a primordial soup of complex organic molecules in water, which eventually assembled into protocells. And it could be that Enceladus' ocean contains some of the right ingredients for life to start. The ocean is believed to be about 273 Kelvin, which under normal circumstances is the freezing point of water. But given that this ocean is salty, the true freezing point would be a bit lower than this, so there's no freezing throughout the ocean. Additionally, Cassini's analysis also indicates the presence of hydrothermal vents. So what we have is a very similar setting to the deep-sea hydrothermal vents we have on Earth, where simple life is known to thrive. Given that Enceladus' ocean is believed to be about 1 billion years old, life as we know it could exist in primitive form around these vents. From what we've seen, it's clear that Enceladus is a world that is begging to be explored. Cassini has been mentioned a few times in this video because much of what we know about it comes from its many flybys of Enceladus, including its subsurface ocean. However, Cassini was never designed to explore Enceladus in detail. It was equipped with instruments that would better our understanding of the ringed planet. Thus, there is strong demand for a dedicated mission that will revisit Enceladus to study it in much greater detail than Cassini, and several such concepts have been brought to the table. Perhaps the most realistic proposal is NASA's Enceladus Orbilander. It is scheduled to launch in the late 2030s using NASA's new Space Launch System, or SLS. The mission will be split into 3 phases. The first phase of the mission involves the Orbilander performing a 4.5-year tour of Saturn's other moons, including Titan, Dione, Tethys, and Rhea, along with flybys of Enceladus. The second phase of the mission will be a 1.5 years long, and it will orbit Enceladus alone. During this time, it will pass through the plumes ejected by Enceladus's tiger stripes and analyze its content. It will also take a series of high-resolution photos to search for a safe landing spot. This will be when we see high-resolution images of Enceladus never seen before. Finally, once this spot is found, the third phase of the mission is executed, the landing. The process will be very similar to the technology used during the OSIRIS-REx mission, which landed on the asteroid Bennu and returned a sample to Earth. The Orbilander will slowly descend upon the surface and have a soft landing. Unlike OSIRIS-REx, it won't bounce off the surface. The Orbilander will permanently be on the surface. Using onboard instruments, it will catch some of the snow produced by the cryovolcanoes and process these flakes to look for biosignatures. Because these flakes come directly from the underwater ocean, biosignatures found from that will strongly suggest the presence of life under the surface. To help with scientists' understanding of Enceladus's interior, it will also study the seismological activity under the surface and detect quakes. Perhaps these could be called ice quakes. And of course, it will also send photos back from the surface, making Enceladus only the 5th extraterrestrial object of which we have photos from the surface. As of November 2025, only the Moon, Mars, Venus, and Titan have had their surfaces photographed from the surface. For the reasons we've seen, Enceladus is one of the most hyped up places in the solar system for the possibility of life. We live in an era where humanity can potentially answer the question of whether life can exist outside of Earth. There are JUICE and Europa Clipper, which will shed light on the icy moons of Jupiter in the late 2030s. And if the Orbilander is selected to develop, we could get answers from Enceladus in the 2050s, which is when it is scheduled to arrive. Indeed, it is an exciting time to be alive.